All right, so we spent the entire block last time doing nothing except figuring out which quadrants these belong in. Do you remember it was very specific? Because remember we highlighted the parts that you're allowed to keep? Because if you go any further, then you break the vertical line test. Okay, so you're only allowed to keep tiny little bits of these. So the odd functions, we're going to write this, this is your notes. We're going to write our little note at the top of the paper. The odd ones were in which quadrants? 1 and 4. Good, perfect. 1 and 4. And the odd functions are sine, cosecant, and then which other two? Good, tangent, and then the reciprocal ones go together, all right? If it is positive, it will be in quadrant 1. Does that make sense? Positive would be in quadrant 1. Everything is positive in quadrant 1. If it's negative, it'll be in quadrant 4. This is the only two you're allowed to be in. You're not allowed to be anywhere else. Remember me using the analogy? It's like you're driving along and there was a bridge, but the bridge is broken. You can't go any further. It's all the further you're allowed to go. All right. If it is even, which two quadrants were we in? Yep. You always start with 1. So 1 and 2. And the ones that are even are cosine and secant, the other two. Basically, remember, they're all odd except for those two. So if it's positive, it will be in quadrant 1. Everything's positive in quadrant 1. If it's negative, it'll be in quadrant 2. Okay? You will never be in quadrant 3. Hey, Ms. Cool, will we be in quadrant 3? No. All right. Other thing I want to mention, sometimes it is written arc, whatever the trig function is, and sometimes it is written with that little -1. Those are two different forms of notation that mean the exact same thing. I don't know why there's two different ways of writing it. They're like synonyms, all right? They both mean inverse. Cool? So do you see how this is positive? What quadrant are we in? 1. Draw a triangle in quadrant 1. Do you remember how drawing and labeling a triangle is your work? Same thing now, we're just doing it backwards. Instead of having the angle and getting the sides, you have the sides and you're getting the angle. It's not any different. You're just doing it backwards. Okay. Now sine is the y value. So that 1/2 goes where y is. What does that mean is the other side? Good. Perfect. What is the angle that goes across from a half? This is why I had you play that Quizlet last time to review this. 1/2 is the little side. So what's the little slice, the little angle? Pi over 6. Good. That is your work. Okay. Now the answer is the amount of rotation. I'm going to make this be red. If we rotate forwards, we went pi over 6. If you're in quadrant 1, whatever you get, that's just your answer because you didn't go far enough for it to be anything different. Okay. Let's try it again. Now, when you look at this one, do you see how it's -1? Instead of a triangle, that's going to be what? A circle. Good. Now, I'm looking for a word like up, down, left, or right. Where is the y value? Because again, it says sine. We want where the y value is -1. Up, down, left, or right? Down. Good. Right here. 0, -1. That is your work. That's the amount of work I'm looking for. Now I'm going to put the rotation in red. These quadrants don't exist. Again, it's like the bridge is missing. You can't go forwards to get there if this part is missing. You have to go backwards. It's kind of like you see that like road closed detour sign. You have to turn around and go the other way. So what is your amount of rotation to get there? It's not 3 pi over 2. You can't go forwards. You have to go backwards. It's -pi over 2. Do you remember last time with your check your understanding and you checked off all the possible answers? That's why I had you do that, is so that when we do this, you understand like that's where your answers are. That's why we took an entire block to do that. Right? Now this one, you cannot get an answer. You can't even do the problem at all. Why not? Yeah, what's the furthest you can go on the unit circle? 1 unit, like the radius is 1. You can't get to 2. Do you get what I'm saying? The circle radius of 1, you can't get to 2. So it's a not doable problem. I just wanted to bring that up. All right, this one again is going to be a circle. I'm looking for a word like up, down, left, or right. Cosine, though, is the x coordinate. So where is the x coordinate 1? Yep, good, right there. Now, there's nothing for me to highlight in red because you didn't rotate anywhere. And so what's the answer? You did not rotate at all. Yeah, 0 pi, no pi. My circle got a little weird. You do not have to put the pi. I strongly suggest it though, because people mix up that 0 with this 0, but I won't mark it wrong if you just put 0, obviously. All right, but that's an amount of rotation and that's a coordinate point. So I just want you to understand the difference. All right, here this one is negative. We will not be in quadrant 1. So look at which function it is. Which quadrant will we be in? I wrote them at the top of the paper. Look at the margin up there. If it's negative for cosine inverse, which quadrant are you going to be in? 2, good. 1 if it's positive, 2 if it's negative. I broke my pencil. I'm gonna have to write with pens, so I hope I don't make any mistakes here. All right, so draw yourself a triangle in quadrant 2. Cosine is the x coordinate, so that goes down here. Do you see why it's negative? So you went to the left, it's in quadrant 2. What does that mean the other side is? Yep, square root of 2 over 2. And that means your reference angle is pi over 4. That is your work. Now the answer is not pi over 4 though. If you're in quadrant 1, you just get whatever you get. But it's the amount of rotation it took to get there. So if you're in quadrant 2, how far did you rotate to get there? It's 3 pi over 4. Very good. Keep calm and know the unit circle. Number 6 is tricky because when you see that 1, doesn't it make you think of the circle? Up, down, left, right? But how do you get tangent from your unit circle? It's y over x. So since this is positive, we're going to be in quadrant 1. What would be the sides so that you end up with 1? Good. Anything over itself is 1. That's me over there. All right, so what is your angle? Pi over 4. And if you're in quadrant 1, whatever you get just is your answer. You rotated to pi over 4, so your answer is just pi over 4. If you're in a different quadrant, that's where you sort of need to worry about it. But if you're in quadrant 1, that's just your answer. All right, for this one, do you see how it's negative square root of 3? I hope your initial reaction is square root of 3 is not on the unit circle. It needs to be square root of 3 over 2 or a half or something like that. I hope that's your initial reaction. It's like, hey, that's not right. What you're going to do is come over here to the side in the margin, and I'm going to rewrite that as negative square root of 3 over 1. Anything you can put over 1, it's itself. Now don't look away. I want you to see me do this because it's real simple. All you're going to do is put them both over 2. And do you see now how it's square root of 3 over 2 over a half? I brought it back to things that are on the unit circle. All right, now we decide what quadrant. See how it's negative? That means it can't be quadrant 1. For tangent, where do we go if it's negative? Look up at the top of the paper. I wrote it for you. 4. Good. Draw a triangle in quadrant 4. And tangent is y over x. So the negative square root of 3 over 2 is the y. The 1/2 is the x. And so what is your angle across from square root of 3? That's a big side, so it's going to be the big angle of pi. Yeah, pi over 3. Perfect. Your answer is not pi over 3. You had to rotate backwards to get there. So your amount of rotation is what? Negative pi over 3. You had to go backwards to get there. If you're in quadrant 4, it's going to be negative. Again, think back to those boxes I made you check, and you checked off all the negative ones. Now this one, if you're like, oh, it's -2, we can't do that problem. We actually can because this one is secant. We're going to flip it over. Anytime you see a secant or a cosecant, you want to reciprocate it. Which function is the reciprocal of secant? Is it sine or cosine? Good. So it's cosine inverse, and you just do the reciprocal. So what's your reciprocal of -2? Yeah, good. Only it'll stay negative. So -1/2. And then that's an easier problem. It's not in quadrant 1 because it's negative. For cosine, where do we go if it's negative? Second, good. Draw a triangle in quadrant 2. Cosine is the x or the y? X. So that -1/2 is your x value. What does that mean the other side is? Square root of 3/2. And so what's your angle across from square root of 3/2? Pi/3. Your answer is not pi/3 though, because you're not in quadrant 1. How far did you rotate? Do you guys see what I'm labeling in the red here? I don't know what's red. How far did you rotate to get there? If this is pi/3, how far did you go? Yeah, 2 pi/3, good. Nice. This is going well. Do you see how this one is cosecant? What is the reciprocal of cosecant? Sine. Good. So it's going to be arc sine. Again, that just means inverse. Now, without me having to do like a margin problem and all of that, do you see how there's a square root of 3 in there? And 2, what, like, let your instincts kick in. If you reciprocate that, what do you think you're going to get? Yeah, and you're right. It's square root of 3/2. It has to come out to something on the unit circle or it's an undoable problem. And I'm not going to give you an undoable problem. Right? What quadrant are we in for this one? First, why are we in the first quadrant? Positive. Sine is the y value. So that goes here. That means the other side is 1/2. What's the angle? Pi/3. And because we're in quadrant 1, that's your answer. All right, we'll do one more and then I'll give you a break. I hope that your reaction is, hey, square root of 3 is not on the unit circle. It needs to be 1/2 or square root of 2/2 or square root of 3/2. Here's what you're going to do is off to the side, you're going to take that square root of 3 and put it over 1. Anything is itself over 1, and then don't look away while I do this. If you look away, you're going to miss it. You just put them both over 2. And now you're back to something that's on the units. So what quadrant are we in for that one? 1, because it's positive. How do you get cotangent? X over y. Good. So this is x, and this is y. X over y. So square root of 3/2 is the x. 1/2 is the y. What's your angle across from 1/2? Pi/6. And because you are in quadrant 1, that is your answer. All right, so for these last ones, they are not on the unit circle. So you are back to Pythagorean theorem. Do you remember that? A squared plus b squared equals c squared. It's not hard, but you just have to work it out, okay? So we're going to do sine of tangent inverse of 3/2. Here's what you want to do. Ignore the sign that's outside. We're going to, take care of that in just a second. This is going to give us our triangle, and then we're going to do sine using that triangle. So first of all, what quadrant are we in? Well, 3/2 is positive, so what do you think? 1, quadrant 1. Now you're also back to SOHCAHTOA. You can't just go sine is y, cosine is x, blah, 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 because it's not the unit circle. So how do you get tangents? Using words like opposite, adjacent, and hypotenuse. Good, opposite over adjacent. So 3 is opposite, 2 is adjacent. So opposite over adjacent. This is your angle. Do you remember theta, good old theta? If you want to call that theta, you can. All right, and then we're going to do Pythagorean theorem to get the other side. So it's going to be 2 squared plus 3 squared equals, what do you want to call it? We can call it R, you can call it C, you can call it X. It really doesn't matter. What do you want me to call it? I have to pick a letter. X. Okay, we'll go with X. So that's going to be 4 plus 9 equals X squared. That's 13. So square root of 13. These are going to be messy answers a lot of the time, so you're going to have weird square roots in it. All right, so that's our work. Did you follow me there? We'll still together? Now you're going to do sine using that triangle. So how do you get sine? Using words like opposite and adjacent and hypotenuse. Good. So that's 3 over square root of 13. And then that's going to rationalize to be what? Good, perfect. Again, they look messy when they're not on the unit circle. Actually, they look kind of messy when they're on the unit circle too. So, all right, let's try it again. I'm going to cover up this tangent outside. We're going to just do the inside part. First of all, it's negative, so it's not in quadrant 1. Look back at cosine. What's your other quadrant for cosine? 2. So draw a triangle in quadrant 2. We spent an entire block last class going over which quadrants they belong in for this exact reason, because if you can't figure out what quadrant it's in, then you're kind of sunk for the rest of it. All right, how do you get cosine? Good. So -5 is the adjacent, 13 is the hypotenuse, which I started writing in the wrong spot. How did I know that the 5 got the negative and not the 13? Yeah, you went in the negative direction. Also, the hypotenuse can't be negative. Now, if you remember, this is one of the Locker combination ones. If you don't remember, we'll have to do Pythagorean theorem, but does anyone remember it? 5 something 13? What is it? Anyone want to give it a guess? Okay, that's all right. Okay, we're going to do the Pythagorean theorem. -5 squared plus x squared equals 13 squared. That will be 25 plus x squared equals, do you know this one? 169. Subtract 25, what's that going to be? 144. Square root 144 is 12. If you didn't remember that one, fine. We worked it out. Do you remember the triple I told you to remember? The one that's really tiny numbers? 3, 4, 5. Okay, good. Makes me happy. All right, that is your work. Then you're going to answer the question. Tangent is opposite over adjacent. So that would be 12 over -5 is your answer. So the part in the parentheses, like the insides, that gives you your triangle, and then you do whatever the outside is to get your answer. Now, these ones don't even have any numbers. They just have u. First thing I'm going to tell you to do is put u over 1, because you need it to be something over something to be like opposite over adjacent or adjacent over hypotenuse, whatever it is. So put a 1 in there. Now, I don't know what u is, so we're going to assume it's positive and just draw these in the first quadrant. If you don't know, just go ahead and assume it's positive. So tangent is opposite over adjacent. It's going to be u is the opposite, 1 is the adjacent, and then we're going to find the hypotenuse. So you have to do Pythagorean theorem. So 1 squared plus u squared equals x squared. And I realize at that point, you're like, wow, there's a lot of letters in here. Remember, you're trying to get x by itself. So what would you do to get the x by itself? Okay, now listen to me. You can't cancel anything out. So just do nothing. All I'm asking you to do is nothing. Can you do that for me? Okay. When you square root both sides of this, those don't cancel. Put parentheses around it if you think that you might forget. All right. So it's going to be square root of 1 plus u squared. You can do 1 squared is 1. That's fine. 1 times 1 is 1. But that squared and square root will not cancel. If it was by itself, it could, but it's 2 totally separate things. So you have to leave it alone. All right, that is your work. Then you answer the question. It says sine. Sine is opposite over hypotenuse. I'm going to write down here because I have more room. It's going to be opposite, which is u, over hypotenuse, which is that awful messy square root that we got. And I hate to tell you, but you have to rationalize that. So it's going to come out to u, and then what? The thing, right? Over 1 plus u squared. Good, you guys came with me on that. If it looks awful, you probably did it right. All right, last one. I'm going to cover up the tangent. We're going to assume u is positive. Draw it in the first quadrant. How do you get cosine? Good. Perfect. U is adjacent, 1 is hypotenuse. You're awake. You're doing really well today. You're awake today. It's good. All right, so you're going to do Pythagorean theorem to get this other side. It's going to be u squared plus x squared equals 1 squared. And again, I realized then you have a u and an x. It's like, wait, which one are we looking for? You want to get x by itself. So what would you do to start to get x by itself? Good, minus the u squared. So it's going to be 1 minus u squared. 1 squared is 1, so you can just put 1 there. And then your last step is to square root that. And if you could just do nothing for me, that'd be great. Do not cancel any of that out. So that is your work. Then you answer the question. It says tangent. Tangent is opposite over adjacent. So it's going to be that awful square root that we got over u. It's the exact same process. There's just no numbers in it. So you just leave the variable placeholders in there.